também o diretor do Sustainable Earth Institute. Suas principais áreas de pesquisa estão relacionadas, então, obviamente, à divulgação e comunicação em geociências, mas também com mudanças climáticas, riscos naturais e energias renováveis, geoenergias. Né? Ele é o patrono do English Riviera Geopark, também no sul da Inglaterra. Ele foi presidente da UK Earth Science Teachers Association. Este ano, ele foi também escolhido para ocupar uma cadeira da UNESCO, a UNESCO Chair in Geoscience and Society. E ele recebeu a medalha presidencial da Sociedade Americana de Geologia. Bom, mas todos, ou pelo menos a grande maioria, conhece ele pelos seus documentários da BBC. Tá? Então, ele está aqui conosco, obviamente, para falar de comunicação e geociências. Então, por favor, recebem o professor Iain Stewart.
It's not, my camera doesn't do it very well, so I'm going to have to take 2 pictures. I just Photoshop them together. Add more people in. Thank you. Look at you turning up on a Tuesday night, and you should have better things to do. So we've had fun over the last day and a half talking about geology and why we're not normal, and you know, try how we get geology out to the public. And that's kind of what I do now. So I'm going to take you through really some of the ideas that are important to me in terms of communicating geology. And I'm going to try and make it not too, some people have been sitting through this for a day and a half, so I'm going to try not to repeat it too much for those who have been sitting through. So a few years ago, I was in a program called How to Grow a Planet, and as part of that program, the BBC put me in a box. They put me in a box. This is a place called the Eden Project in southwest England. If you've been to England, you may know it's a kind of like a Biosphere 2 type project. And they put me into this box. It's an air sealed type box. And I had to stay in that box for 2 days. 48 hours inside that box. They took the oxygen levels down from 21% to 12%, which is getting pretty close to dangerous levels. And the idea was quite simple, was could I survive by, in that box, being helped by the plants? In other words, the plants would use my CO2 that I breathed out to photosynthesize, to pump out oxygen, which would then allow me to live. So it was kind of, for chemists, you might know the Priestley experiment, where they first looked at that the plants were producing oxygen. So this was the great experiment, using me instead of a mouse or a plant. Could I survive with these, with just these plants? There was a doctor on hand. This photograph makes it look as if I haven't seen a woman in months. It's not. It's just like day 2. I'm kind of tired, and my job was to lie in a hammock for 2 days and really not do anything except to look after the plants. Every green thing that you see there was potentially putting out oxygen for me. And so I had to look after the plants, keep them watered, make sure they're okay, because every damaged plant was less oxygen for me. And so here's the record. We published a paper on this, on extreme physiology. This is my 48 hours in the box, and this is the carbon dioxide changes. And so you'll see that when I go in, the CO2 starts to rise because I'm breathing, and it goes up pretty fast. This is when I'm sleeping. These are my sleeping patterns. See the CO2 rising, and then gradually it takes about 24 hours. It takes about a day before the CO2 levels start to really come back down again. And that's because this is what the oxygen is doing. So you see the oxygen was taken down to almost 12 degrees. That's normal atmospheric up there. And then gradually over the course of the 48 hours, those plants pumped out oxygen and made up for the CO2. The key thing, I guess, with this is to point out is that I did nothing, really. I had no exercise, no energy expended. Those plants were chosen to be high photosynthesizing plants, specially chosen, and it was packed full. And I needed that box packed full of plants just to keep me alive. So it's an interesting perspective on the planet when you suddenly realize how much plants an individual needs to stay alive when I'm basically doing nothing. So imagine what I need if I'm running, I'm active, etc. And imagine a lot of the greenery, the plants out there are not high photosynthesizing plants. So it's an interesting perspective on the planet. Now if we look at the planet, you'll know this graph. This is the CO2 record for the planet. Back from 1957, this is the measured CO2. You see the rise and fall progressively. And this is one of the key data sets in the idea of anthropogenic climate change, human-induced climate change. So I've got a question for you, because what we kind of know is that most of the CO2 rise, the accelerated rise, is a result of burning of fossil fuels, etc. And at which point do you think, in this timeline, from the measurements being taken in 1957 to where we are now, at which point do you think the highest level of the US government is aware of fossil fuels and climate change as an issue? So if I stick myself in the middle of 85, should I go to the left or to the right?
Left.
To the left? You think earlier?
No,
Where do you think?
I think.
To the right? You're out voting. So where should I go before the US, like I said, administration, US president talks about climate change and fossil fuels? Where should I stop? Keep going? Yeah? Right about here, so 1995, you're out by 30 years. 1965. 1965, President Lyndon Johnson, in his State of the Union address, says this: this generation, so not your generation, previous generation, has altered the composition of the atmosphere on a global scale through a steady increase in carbon dioxide from the burning of fossil fuels. That's really interesting, because that's 60 years or so ago. 60 years ago, the administration recognizes this is a scientific problem. And yet, for many people, still today, this is seen as questionable or it's certainly, barriers to actually doing something about it. So the science was kind of clear and really clear back here, 1965, and yet we're still a political football about climate change. What is less clear is the dramatic changes that are happening in the planet over the course of that period. So this is a set of indicators from natural systems, and in each of these, if you can see, there's a dashed line, and that is 1950. So just about the time those measurements were starting. Am I moving around too much yet? Well, can I just stay here? I'll stay here. Around about 1950, and almost all these graphs, there's a step change in the way the planet systems work, and that is as a result of the post-war economic boom that's happening across the planet. And it's not just the natural systems, here's the human systems. That change is what anthropologists refer to as the great acceleration. Suddenly, humans are acting at a planetary scale. We're affecting the natural and the human systems. There's a change in state that's happening, and that's really important. And something else that's important, 2015, 3 years ago, there's 3 major frameworks for the planet that get put forward. Top left, the Sendai Framework for Disaster Risk Reduction, about how we're going to reduce disasters over the coming up to 2030. The 2015 Paris COP21 agreement on setting a roadmap for climate change. and then the United Nations Sustainable Development Goals, which is a set of ambitious targets, each of these with metrics underneath about where we need to get to if society and the way that we think about it now is kind of going to survive. I mean, for some of these things are potentially existential, particularly changes in the ocean. That's interesting because it means that you guys here are entering science at a time when there's a roadmap for how science needs to address the world's problems. And we've never had that before, this idea of how science, the responsibility of science to address some of the big societal issues that we have. So, I'm in here in the geology department and I'm a geologist, so there are a whole set of issues relating to geology that are critical for these future decisions. About where we're getting materials to build our cities, about where we're getting the metals and minerals to drive our modern world. Everything that people want in the modern world, most of it, comes from things that we dig out of the earth. Energy, top right, that's the dirty fossil fuel energy, but there's a shift into new renewable energy. That'll still need geoscientists in some kind of form, and oil and gas is still going to be around for some time. Clean water, issues to do with climate change, and issues to do with pollution related to the planet. All of these are earth science issues that demand geoscientists to engage with this. So, so that gives us to the top. My talk is really about how we communicate the planet, the importance of the planet, and our role as geoscientists in studying the planet. That's the critical bit. So I'm Professor of Geoscience Communication. Science communication might seem new to you. What is it? So this is my landscape, if you like, of science communication. There's lots and lots of stuff that can be included under science communication. This plot tries to make sense of it in two ways. It says, what is the motivation of scientists? That's on the vertical axis. So down here, the motivation of scientists is science, pure science, just interest. So it's academic. But as we move up this axis to the top, we get to the motivation to solve society's problems. It's problem-oriented. Along this side is, to what extent is the public involved in our activity? So down here, low, if at all, and as we move across here, a higher amount of participation. And the vast majority of academics live in this little bit down here, this little quadrant. In other words, we're driven by knowledge, and the public isn't really involved, isn't a concern in our activity. Every so often, scientists want to do more, and they drift this way, maybe give a public talk, maybe write a popular article, maybe produce an internet film, a YouTube film or something like that, their topic. But I'm going to talk a lot about what happens up in this area, up here, particularly television science, because that's where I've done most of my work. And what I want to do really is see what can we learn from television science when we're reaching large audiences, popular programs. What can we learn from that maybe we could feed back into more fundamental communication of our science? So this area here traditionally gets referred to as the public understanding of science, how we educate the public about science. And this area here is referred to as PE, public engagement. Just getting the public interested in science, bringing them into our world in some ways through us going out to them. By the way, how many people here on social media? So how many people are on Facebook? Everyone. Okay, that's interesting. Twitter? Not so much. Instagram? Oh, I see Instagram. But actually, Facebook. A lot of people with Facebook. So that's a place where that is often more of a public realm that scientists are talking. But anyway, let me tell you about television science. So I work a lot with the BBC and radio. Let me bring them up. Over the last 15 years, I've been making programs about the planet in some way. So this is I feel sorry for Eduardo.
That's fine, don't worry.
I'm just going to stand in this little bit. So all of these are about trying to sell the planet in some way, trying to talk about the Earth, how it works, what it means to us in different ways. And I've kind of talked in the last day or so a lot about some of these programs and what we've done. I'm not going to do it here. What I thought I'd do is show you a clip of programs. So some of you have seen them and some of you haven't. But this clip will kind of explain the style of the program, if you like, what they're like. So anyway, let me take you to Siberia.
The best place to see what effect global warming is having on the permafrost is the many lakes found in this region. And that's what's brought ecologist Katie Walter to this frozen wasteland. She believes she's already detected the first signs that methane is being released from the permafrost.
Inside the permafrost is a very large volume of dead plants. And what's happening is that the permafrost is melting and thawing and slumping into the bottoms of the lakes. Those dead plants thaw out and they ferment in the bottom of the lake, and methane is the byproduct. Methane comes out.
If Katie is right, then we should be able to find methane almost everywhere.
This is the ice. That's the ice. Look at that. That's beautiful. What a sponge.
The ice is over a metre thick, and it's obvious that it's full of bubbles trapped inside it. The trouble is, it won't stay trapped in these bubbles for long. When the ice thaws in spring, the gas will escape.
Methane is a greenhouse gas that's 23 times stronger than carbon dioxide. So we're very interested in understanding how much methane is coming out of these lakes.
There's one sure way to check just how much methane is in these bubbles, because it's highly flammable.
Wow! My God! Woo! I can't believe it's a fire coming out of mine.
Isn't this amazing?
That's the real
We're on a lake in Siberia,
Can't do it.
and the lake is burning. It's pretty amazing, huh?
That's
It never ceases to surprise me.
Alarmingly, these bubbles can be found all over the place, which means there must be enormous amounts of methane trapped here.
Whoa! You okay?
Yeah.
You ready? Ooh.
Oh, that's nice, isn't it?
This place is just full of these.
Ice is one of the most bizarre things I've ever seen, but it has very serious implications.
So as I say, it's clearly not something a proper academic should be doing. It's having fun in the snow. So the interesting thing is that when I started getting into television around about 2002, 2003, so what television does is it kind of takes you out of your academic world and allows you to, like an out-of-body experience, look back at your academic area, and you suddenly realize that things that you thought you understood, you actually don't understand anymore. So this was one of the first programs that I did. We went to Indonesia, we climbed Mount Merapi, which is a really nasty volcano. It has eruptions every 5 to 8 years, pyroclastic flows come down and kill hundreds of people. And we climbed up to the summit, and this is the summit, and here's Rudy, who's the head volcanologist, shown as the monitoring system that allows them to give them many hours, in some cases days, of warning of a volcanic crisis. And that means that the government can undertake a mandatory evacuation of communities living near the volcano or on the volcano. And that's fine. As we walk down the slope, Rudy says to me, of course, you know, the thing is, what's interesting is the villagers don't evacuate. And I said, what do you mean they don't evacuate? And he says, well, we have a mandatory evacuation, but the villagers refuse to leave the villages. And I thought, what? That's just crazy. Why would you do that? Yeah, it's to do with the cultural connections they have, spiritual connections with the volcano will give them some sign. And I thought, this is madness. Volcano science is very well evolved, much better than my earthquake science area. And it's getting undercut, undermined by this weirdness. So I got a PhD student, joined with human geography, and she lived in this area, this village, and she studied why this was the case. And the reason it was interesting was, so the top left is Mar Barajan, who is the spiritual gatekeeper of Mount Merapi, and the idea was that he communed with the volcano and gave certain, the volcano would tell signs if it was going to be dangerous. And it clearly didn't work. This is a village called Turgo, and in 1996, during a volcanic crisis, during a mandatory evacuation, the villagers of Turgo didn't not just evacuate, they held a wedding on a Saturday night. And a pyroclastic flow came through this church hall and killed 30 people. So clearly this indigenous knowledge was not serving a purpose. However, one of the things that Kate found when she lived in these villages was that actually people didn't really listen much, especially the young people, didn't really listen much to Mar Barajan. The reason why people didn't evacuate was quite simple. That in these villages, their income was cutting grass, feeding it to their cow would give milk and they would sell the milk. They could evacuate. Who was going to evacuate their cow? They were making a rational judgment that they were more likely to come to harm by something happening to their cow when they had left, or someone stealing their land, rather than the rare chance that a pyroclastic flow would come down. Now, none of the scientists had thought about this, because they were looking at the volcano science and the physical science. But when you start hearing the stories, that makes it perfectly rational. I think I would probably not evacuate in that instance as well. And it's not just in places like Indonesia. This is California, west of California, north of Los Angeles. And you can see there's a landslide, and you can see just the back scar at the top, and you can see this jumbled mass. It's a landslide, and it's come into a mudslide. And on 10th of January 2005, the hillside gave way, this landslide came down and killed 10 people underneath there. And Jeannie here showed me around. That's Jeannie's house. The mud's actually went up to that first level in Jeannie's house, and they used that window, the firefighters, to go onto the mud mass in this area to basically dig the bodies of our best friends out across the road. And I said it very deliberately, because that was the first time that I encountered a disaster where I actually heard the stories of people who died. That's an important thing. Anyway, Jeannie walks me up the street, and this house here was for sale. And I said, well, no one's going to buy that house. You know, you look out the window and it's got crosses, and every study of this landslide says the same thing. The next time there's a lot of mud on that, a lot of rain falls on that slope, that mudslide will remobilize, and these houses are next. And she said, oh, that's been sold. That's actually gone up in value since the mudslide. Jeannie is smart, and she's affluent enough that if she wants to, she could move away, but she's not. She's decided to stay. And that just confused me, because I suddenly realized that I'd been teaching hazards, geohazards, and I suddenly realized I didn't understand them, because there was something else here that I didn't understand, and that was people. That people, the way human nature, the way they behave, was important. And that's where television comes in, because television is all about people. They're always interested in the audience. Who's going to watch? Would they like this? Can they understand that? They spend most of their time thinking about the people out there. And it dawned on me that as a scientist, I'd never thought about the people out there. If I turned up to give a talk or I went into school, I never thought about what the people were interested in. I just knew what I wanted to say. In television, you can't do that. So I want to talk about how we think about the public in terms of not just television, but in science communication and in things like marketing and advertising. In all of these areas, you try to understand the public really well. You try and break them down into different types, because each of those different types demands a slightly different communication style. And if you're going to be a good communicator, you have to be thinking about who's my audience and how do I reach them. So anyway, this is a survey that the Australian research organisation, CSIRO, have done. And the first thing they've done is they've broken the public down into different types of people. So apologies to those who've seen this over the last few days, but one group of people is what's referred to as the science fan boys and girls. You, although you didn't know it, are science fan boys and girls. You're close to science, you understand science, you're interested in science. You probably watch science documentaries or read the odd science article. You will have discussions about science, different types of science. Then there's a group roughly the same size called Mr. and Mrs. Apple. Perhaps they're the mum and dad of the science fan boys and girls. They like science, they're interested in science. Science is a little bit further away from them. They might watch the odd popular documentary, but they probably wouldn't read a science article in the newspaper. And if they were having a discussion about science, pretty quickly they'd realise they didn't remember it as well as they thought they did. Then there's a group that tends to be a little bit elderly, called I Wish I Could Understand. But this is an interesting group because they're the group that actually goes to science museums and science centres far more than any of the others. They really want to like science, are fascinated by it. But when they get to the museums, they can't understand the science the way it's presented to them. They get very frustrated by this. Then there's a group that says, I don't like science. I hate science. I really hate science. Like when I was at school, my chemistry teacher beat me up. And I absolutely detest science. But this one's quite a small group. But there's another group that's kind of interesting, is people that just have more interesting things to do. They're interested in politics, or music, or art, or something. They say, it's nothing about science, I don't mind science, it's just I'm too busy to have science in my world. And then finally there's a group that is quite small in this one, but they are interesting. It's a group that says, I don't need to know about science because I know how the world works. So I've got religion, or I've got some pseudoscience philosophy that explains how the planet is. I don't need science to tell me that. And they're quite small in this one, but they're very vocal, and they spend a lot of time shouting. So one of the things is that these are all different publics. They're all part of the public, but they're all different publics. And certainly in television, if we're trying to the kind of programs that I make, the key people for me are probably the core of my audience are probably in here. Yeah, this group here desperate to have science presented to them in an interesting way. This group here that are interested in science, and but like, kind of want to see it refreshed. Later on what that one is. But I'm also interested in getting a bigger audience for science. So I kind of want to get some of these people. The way I have to do it is I have to present science in a way that doesn't look like it was done at school, because that's what's turned them off. So I can do it in a different way, like getting my face blasted off by a sheet of gas coming out of the ice. Then that's fine. I also want to get some of these people. But they're busy. So what I have to do for this lot is to connect with the things that they're interested in. So if they're interested in politics, then it's the political dimension, the geopolitics of it. Or if it's art, it's talking to them about how rocks and minerals are really important for art. Whatever it is, draws a few of them in this way. And I'm not really bothered about them, because they're probably going to write to me in red crayon telling me that gravity is wrong anyway. But the interesting point is I'm not going to design my programs for you. Why am I not going to design my programs for you, this group here?
Because you're going to watch it anyway.
Because you're going to watch it anyway. I'm sorry, I don't. So you're going to watch it because you're interested in it. I can't mess you up. I have to be careful I don't mess up. But really, I'm targeting this group in the middle. So I'm not making programs designed for you to be presenting them in the classrooms. It's nice that you are, but that's not the point. My point is to try to reach that group. So that's what I mean now. Right. So the Australian study is interesting in another way, is that it also looks at values and beliefs. Those are the things that sit beneath the interest. These are the things that really determine how people think. And the way that they get at that is they ask what's called value-laden questions. So you might not be able to see them here, some of them. So look at the top. The benefits of science are greater than the harm, or science tends to benefit the rich more than the poor. So there's a whole suite of questions that people get asked, and then people judge how strongly they agree or disagree, and that then lumps them into different value groups. Does that make sense? So you get based on, discriminated on the basis of your fundamental beliefs and values. Let me show you what that looks like for science. So on the basis of values, this study identifies 4 groups. And here they are, in terms of increasing interest in science towards the right-hand side. So there is some kind of overlap a little bit. So the ones that have to see the most value in science, is referred to as science fans. For that group, science is good. It's a power for good in the planet. It's not too scary, it's not too fast. It is the solution of many of the world's problems. For the cautiously keen group, yeah, science is okay, it's got some answers, but there are other things out there too. You have to be careful with that. For the risk averse, science messes everything up. It becomes turbulent and chaotic. Why can't we just go back to that nice little world we used to have before science came along, right? This particular science, stem cells or whatever it is. And the last group, we've kind of met them. They're either concerned about science, science is the problem, it creates all of these things, or they're caring about other things. They're disengaged from science. So what I'm going to show you now then is some of those value questions with these different 4 groups plotted out. And the interesting thing is to look where you are. So the green group, let's see where the green group is. And there's something interesting, I think, pattern recognition. Don't get hung up too much on the detail. There's something interesting about green. Shout out if anyone sees anything interesting about green as a pattern recognition, except for those who talked about it earlier, obviously. Anything jump out? So it's green as opposed to the other groups. Don't worry about questions. Questions are kind of irrelevant. No way. Any thoughts?
A little bit isolated, no?
A little bit isolated, yeah. So, so one thing is we're on the edge. So it might be the left edge or the right edge, but we're on the extreme. But it's more than that. We're disconnected. We're decoupled from the other groups. So in the top one there, B and C, in that one, share some common values. There's some overlap between them. In this one here, B, C, and C and D share some values. So the group C overlaps with 2 different ones. In fact, down here, even D and B share some common values. But on the face of it, none of them share common values with us in many of these issues. So we are, in value terms, the outlier. So we think when it comes to science issues that we are the important group. We hold the answers, we are the experts and all the rest of it. And that may be the case. But in terms of the way the other people see the world, we don't share, not the other publics out there don't share those same values. And that's why we're isolated in many respects. So the conclusions then of the study, and this is a study that really summarizes kind of 40 years of empirical social science, psychology, anthropology, sociology, communications, about how people understand things. It's not just one study. So here's the conclusions. When information is complex, people make decisions based on their values and beliefs. What that means is they could go and read all of the complex information that's out there, but they don't. They choose instead to go with their gut instinct and they make a very quick judgment and they go with that. That's the problem. Second, people then seek to confirm or affirm those attitudes no matter how weird they are. In other words, if they think something, they can go into the web, the internet, and they'll search the internet until they find someone, somewhere, in some part of the world that believes what they do, and they go, look, I knew I was right. The fact that they've gone through 99.9% material they're told them they're wrong is irrelevant, because that's not what they've been looking to do. They're looking to strengthen, to reinforce their values, not to have their fundamental values questioned. None of us like our values questioned. We like them to be told that, of course, we're right. The one that concerns that previous one, people most trust those whose values mirror their own. Trust is used in society as a way of kind of a cognitive shortcut. In other words, I could go and understand this complex technical, or I could go and ask someone I trust, and when they tell me the answer, I'll accept that. So because I trust that person, I trust their information. And that's the point. If we're not that trusted group, if we're in a different value group, then our information is irrelevant to that person. It doesn't even come into it. This next one is probably the big one for us as scientists. Attitudes that aren't formed by logic or facts aren't influenced by logical, factual arguments. So if you go to the top one, if someone said, I don't like climate change, I don't agree in climate change, and it's a gut instinct, a feeling they've got because it's something how offends their values. It doesn't matter how much you tell them about temperature increases or CO2 records or sea level rise estimates. That's not why they've not liked climate change, because they are making a judgment on their instinct and their gut feeling, and we're making on this logical, factual argument. So the overarching conclusion of this study is public concerns about contentious science or technologies are almost never about the science. And scientific information, therefore, does little to influence those concerns. That is tricky. If we're saying that scientific information is not of influence out there, we're not saying in science, we're not saying with engineers and planners and technical people, we're saying out there amongst the public. If scientific information is not as important as we think it is, then what have we got? We spend all the time in here getting scientific information. In fact, what we think about science communications, how can we get our information better? How can we get it clearer? How can we get our diagrams better? How can we take jargon away, make it clearer? It's all information. What this is saying is that doesn't work for many of those publics that are hard to reach, the disengaged, and the ones that are, I don't like science, and the too many other concerns. So what have we got if we don't have our factual, logical arguments full of clear, rational information? What have we got? So it's on this point that I think it's useful to go back to television. Because television really isn't about logical, factual arguments all the time. And you may know this because you watch a program of a topic that you have got some idea about for class and get very frustrated. Oh, this is so simple. I can't believe how simple this is. Because it's not about giving over that simple logical arguments. It's about other things. So what I want to do is to walk you through what I think are some of the key ingredients about communicating to mass audiences that might help us when we start to think about what we can do. So one of them is about the wonder, capturing the wonder and awe of whatever it is we study. In this case, studying the planet. And I think let's just see this as a good example. Unbelievable. It's just mad. Absolutely gorgeous, isn't it? This is La Cueva de los Cristales. For my money, the most spectacular cave of crystals discovered anywhere in the world. I've travelled around the world to see some of the most amazing geology, but this place just tops it all. I'm like it. It really looks perfect. You can see through them, it's so translucent. And they're different types. You can see these ones are like roses building up, and then these columns, these pillars. Absolutely magnificent. So what's interesting in that one is really there's no technical stuff there. I mean, that's calcium, that's gypsum crystal, calcium sulfate, really simple. But it's not really about that. It doesn't really matter what the chemistry is. It just looks amazing. And so I like this quote from the author, John McPhee, who's wrote the Annals of the Former World. He says about when the gaps that exist among the facts of geology, the space in between is filled with the geopoetry. So, so we get caught up on the facts, conveying the facts, but we forget the matrix. The matrix that glues it all together is a sense of wonder and amazement about the world we live in. So as geoscientists, if we can capture that fundamentally, then we're one big step in terms of communicating what we do. What's another thing? The drama. What this is about is the controversy. This happens to be fracking. This is methane that's escaping from this lady's tap in Pennsylvania. And you hate it when methane comes out the tap and it lights your tap in the morning. So a lot of geologists get really nervous about talking about controversies, climate change, evolution perhaps, creationism, or fracking, or whatever it is. But that's what the public are interested in. It's one of the first things they're interested in, they want to know about it. So it's, we should use this. I mean, there's precious little times when people are looking to geology and they say, tell me about your subject. So usually it's going to be a controversy. So we need to use these controversies to bring ourselves in. And related to that comes down to the next thing. It's about the so what question. So what this portrays really is in green the way that scientists are trained to work and to communicate. So we start with this broad background, we have broad interests, we learn lots of things, you're all in university at some level learning things now. Then you start to analyse and ask your own research questions, collect some data, analyse it, test it, and you'll eventually, maybe it's a master's project or a PhD or a research paper, find a conclusion, you'll want to communicate that conclusion. Well, the public have it completely the other way around. They start there on that really sharp point, and as soon as you open your mouth, they say, "Oh, stop! Why are you telling me this? What's it got to do with me? Why should I stop my busy day and listen to you telling me about science?" So if you don't have an answer to that, that's the end of the conversation. You don't get anywhere else. But if you do, if you learn to have ways to connect with people, you can pull them down deeper and deeper, and that depends on how good you are, pull them into your world about what you're doing and why it's important. But you have to start with their point about why is it relevant to them, not why is it relevant to you. Another one that leads on from this is communication is not about the facts. That doesn't mean fake news. It doesn't mean that facts aren't important. It just means that facts aren't that interesting to people. What it's about is stories. If you can tell stories, a narrative, and you can put into that story the facts, that people remember the story, and they'll remember a whole bunch of those facts that they need for the story. So you've kind of got some of the facts across, but the key thing is developing what is my story that I'm going to tell. And this is a little bit, you might not be able to see it in the light, but this is from Climate Change, Communicating Climate Change paper by 2 climate scientists. And listen to what they say is important. Try to craft messages that are not only simple but memorable, repeat them often, make effective use of imagery, metaphor and narrative. In short, be a better storyteller. Lead with what you know and let your passion show. I teach lots of students in science and in geoscience, but in the formal teaching, we don't tell you that actually one of your jobs as a scientist is to let your passion show. In fact, we kind of do the opposite. We talk about how technical it should be. It should be the third person. It should be this dry writing up your reports in these kind of ways. And that is the language of science. That's fine. It works in science. But it's lousy out there in the public. It doesn't work. And so what needs to come through is a sense of passion. Another thing is it's fundamentally about people. And that may seem a disadvantage to people who study Ordovician trilobites or Proterozoic stromatolites. There's not many people around then. But the people are interested in people. This is a quote from a paper I wrote with a journalist, but it's Ted's words. And let me read them because get this every time I read this quote. It's a fact often overlooked by scientists that most other people are mostly interested in other people, and they're mostly not interested in anything else. The fact that scientists are more interested on average in things and ideas marks them out, marks me out, marks you out as mentally unusual. We are outliers. We're disconnected from other people because one of the reasons is we're interested in abstract things and ideas. Most people, most normal people, are interested in other people. And you kind of know that. That's why people sit on the bus reading OK magazine, watch, Love Island, or, they're interested in people. So we have people. So these are two wildcat drillers in Pennsylvania that I was filming in the series called Planet Oil. This guy here is 93 years old. He still drills one 90-meter drill hole every week. I was up with them, and these guys are like right out there. I asked them, for example, with their driller, I said, do you frack? Do you inject water down to enhance the return flow? No, he says, no, not really. He says, we have to get the water trucks all the way up here, and the environmentalists don't like it because it's such a mess. So we normally just pop them. I don't pop them? What do you mean pop them? Pop them means drop nitroglycerin down the hole. These are interesting guys, They're the kind of guys you want to hang around with. So the way that we bring people in to our stories in geology is really, really important. We get them, we get characters, use them. But one of the most important people, stroke characters, is the scientist that's doing it. So let me just, so in this case, since we're listening to me, we're drawing me. But let me come back to this. It's just kicked off just as we got here. They call it puffing here. A big puff, and you can see all the boulders just rolling down the hill in the smoke there. God. We've arrived. Hey! Look at that. That's Stromboli for you. Isn't that magnificent? This volcano has been doing this, exploding like this every 10, 20 minutes really for the last 2,000 years. Whoa! That's a good one. That's a cracker. It's so hard to get an idea of the intensity of that, but those orange balls that are getting kicked out there are actually meter-sized boulders. And the temperature of that must be 500, 600 degrees. Extraordinary. You really don't want to be much closer than this. Well, I do, but... What makes Stromboli special is it doesn't really produce that much lava. I mean, unlike volcanoes like Hawaii and Etna that spew out these huge lava flows, this volcano's eruptions are almost exclusively explosive. And at night, when the sun goes down and the fireworks really start, you really understand why it's called the lighthouse of the Mediterranean.
Stromboli's regular explosive eruptions create one of the planet's most astonishing spectacles. But more than that, they're a clue to understanding the process shaping the fate of the continent.
I wanted to let it run all the way through because that last little bit's good for that wonder, that awe kind of thing. But the first part was what I was want to show. We're not normal. But that's a good not normal. Slightly geeky, slightly crazy, but actually that makes us slightly different from other people. We do things that are not normal. That's really works for communication point of view. And the last point that I think is really important is if you're doing science communication with the public, one of the important things is that as an academic, you have to make a really clear realization that you're stepping from the academic world and you're stepping into the public world. And this means you're stepping into the entertainment industry. So the very last one that's important is that you're entertaining. This quote, I'm not going to read, it just says that. It says that really, science communication out there, if you think about that you're in the entertainment industry, you're actually going to be closer to being effective because you can use all the tricks and devices of the entertainment industry in very focused kind of way. So let me just show you this last clip. I think it's the final clip that I'm going to show you before we wrap it up. It kind of tries to put all this thing together about the storytelling and narrative and wonder and that weirdness of being an individual. And let's kind of watch this. No? Okay, let's do this. Oh no! Don't tell me I've not put the clip in. Oh, here we go.
The discovery of Africa's deepest origins started with Livingstone's fateful expedition 150 years ago. As he made his way down the Zambezi River, Livingstone found his progress suddenly interrupted by a strange sight. A huge curtain of mist rising up from the river ahead, accompanied by a steadily increasing roar. Leaving his team behind for fear of putting them in danger, the explorer continued his journey on foot, only to find his way blocked by the most impenetrable of all obstacles. Known to the locals as Mosi-oa-Tunya, the smoke that thunders.
We, of course, know it as the Victoria Falls.
And the ultimate way to experience the falls involves getting your feet wet.
This is the way to see Victoria Falls. Oh my gosh.
While the water around me cascades down more than 100 metres to the river below. This pool forms a hidden sanctuary.
So you should definitely try and do that once in your life. Try and make it September on the Zambezi when the water level is really low. That's quite important. So I want to try and bring this together in a sensible thing and kind of throw forward to how we might look at science communication in a slightly different way. So I've gone back to this thing, this contrast between my academic world, writing research papers, teaching, the usual, and then this world of television science. What I said was, well, what can we learn? Because these programs are great for saying, isn't that an amazing planet we live in? But one of the things that I'm talking about is how do we deal with these big, potentially existential issues related to climate change and sustainable development and natural disasters. And so going back to this, these are interesting because these are issues that we have to be dealing with over the next 10 years or 20 years or 30 years. And they don't necessarily fit in very well into this thing that I'm talking about, because a lot of the kind of programs and things I'm doing there are kind of immediate consumptions, what people want to have now. and how do they make decisions for the long term? Let me give you one very, very quick example. So I work a lot in Istanbul in Turkey. Istanbul is a city that is waiting for a magnitude 7.4 earthquake to strike it. The fault line that runs to the south of it has ruptured. Every single part of it has ruptured in big earthquakes. The most recent in August 17, 1999, an earthquake that killed 17,000 people. The only section of the fault line that is not ruptured is one 20 miles away from Istanbul, and that is a city of 13.5 million people. So over the next 5, 10 years, maybe 15 years if we're lucky, we will see Istanbul hit by an earthquake that conservative estimates say will kill 100,000 people. Now, Istanbul is a place with lots of problems. It's got political problems, it's got social problems, it's got economic problems. People are just hanging in there. How do you communicate something like that to them that might happen in 5 years or 10 years or 20 years? Or it could be, how do we convince the people of Istanbul to talk about climate change? Or any of these issues. These are really hard issues, but this is an event that when it happens will dwarf all of the other problems that that city necessarily has. And I just want to go back to this plot again. I've taken all the detail off of it. I wanted us to think about the way that we would think of a business. The businesses use communication, we call it marketing, advertising and marketing. Now, what's interesting is one of the main modes of marketing for a business is you basically create a product. You have a production line, you make a product, and you sell that product. And all of your attention as a business goes to making that product as simple and cheaply and as effectively as you can. And if it's a good enough product, you have a sales team and they sell it. Yeah? That's kind of what business for the last couple of hundred years more or less has done. And they refer to that as make and sell. And I think that's what 90% of our science communication academic does, is we do some science, we're interested in selling it, and we wrap it up in some nice stories, some nice imagery, we send it out the door, we say to people, buy this science because it's really good for you. And it's driven by us, it's driven by the academics. The second business paradigm that came along in the 1950s was very different. It was a rise of marketing that said, no, what you need to do is to listen to your customer. Who's your customer? What does your customer want? If your customer wants something slower, bigger, faster, greyer, whatever, just change your product. It's the customer that's king. And that sense of marketing is referred to as sense and respond. You sense what the customer wants and you change your production process to do it. You don't care about your production process much as the customer. And I kind of think of this as that domain of sense and respond, where we go out into the public, we're the public realm, we're at festivals, we're doing things with dinosaurs, we're doing things with volcanoes or whatever it is. We're getting people interested in science. It's not really helping us with the fundamental questions about climate change and disasters. Both of these are short term. This is short term because it's short term by whatever the academics are interested in, or whatever the research councils are giving us money to study. This is short term because it's whatever the public are worried about at that particular time. So in Istanbul, they're not worried about earthquakes, so they're not doing anything about earthquakes. So neither of these common modes of science communication, public understanding of science or public engagement, I think are going to address the really big issues that we have coming from us. Clearly, there's a big gaping space in the middle here. And it turns out that there's a third marketing paradigm that's emerged in the last 5-10 years. And that's emerged with companies that have as much attention towards social value as economic value. Companies like Unilever or Patagonia, which have very strong environmental policies and social policies. In other words, for someone like Patagonia, you're willing to buy a slightly dearer jacket or sweatshirt because the company's a good company, does good things. You like that company, so you attract that. And that mode is referred to as guiding co-creation. The guidance comes from the fact that the company, or in our case the scientists, have some idea of where the future lies. However, it's not just up to the scientists. They have to co-create with the audience, with the customer, to get there. If they go too fast or too slow, they lose the customer. So there's an iteration back and forth between scientist, public, or business, customer. And that's what a lot of these business models do. So my view is that we need to create a new kind of mode of science communication, and that means a new mode of science communicators, brokers, knowledge brokers, that understand science and understand the public and are willing to live in this slightly, battle zone between the public and that means certain aspects are normally associated with certainly physical scientists. We have to understand how to be trustworthy, transparent, and ethical. We have to think about the ethics of what we do. That's really important. We need to be interdisciplinary. We need to be understanding some sociology and psychology to understand how that works. We need to be participatory. We need to be involving lots more people in the scientific process. And we need to be reflexive. That means thinking not just about scientific knowledges, but other types of knowledge as well, but what is needed. That is a very different type of scientist than the ones that we create anywhere in the world really today. So that's what, I was going to say that's what I'm trying to do with the Institute, but let me just move on. Let's just get to the kind of punchline here. Because, so there's a one-dimensional frame of science communication. What I'm saying is that time element needs to be pulled by a different kind of mode, and I'm calling it this guide and co-create. It turns out that those companies, like your Unilevers and like your Patagonias, that are have got this social value, also have one thing in common, and that is they have purpose. They have a purpose-driven strategy. And by purpose, what I mean is a pursuit of an ambitious, clear, enduring, and overarching goal, which is motivating. Now, many individual scientists have this, but not many organizations, not many departments, not many institutes, not many universities have this. In fact, I don't know any university that has this. And yet, if business can do it, if your multinational corporations can do it, then places like universities that are places of wisdom that should be thinking 10, 20, 30 years, they should have it. And all of that then is that the purpose of the pursuit that is motivating, I think in academic universities, etc., should be about this, should be about well-being. That our job as scientists is to improve the well-being of the planet, of the ecosystem that live it, of the people that live it. And that's what we should be judged on in terms of that longer term. And all of our science communications, what we do about science, should be aimed in the direction of well-being. And with that, I'll thank you very much. Thank you. I'm conscious of time, and some people might have to leave, in which case just leave. But I'm happy to stay and answer questions if people want to ask questions. So.
Well, I have a question.
Yes.
Well, sorry for maybe I'll try to be understandable.
So I.
So you showed us many interesting and captivating examples of science subjects.
Yeah.
Sometimes maybe some types of research or science subjects may be not very captivating, or I mean, doesn't have all that glamour or fantastic stories related to it. So, do you think that those subjects, well, if they are related to well-being, they are well, they deserve to be communicated, right? But how to do that if you don't have, if you are in a difficult situation?
Have you got an example of something you think might not be captivating? And I don't know what do you work on?
I work with caves, and well,
it's pretty interesting.
yeah.
Maybe you're not using that as it.
No, I was not thinking about use caves as an example because I think that caves are like volcanoes or
I agree.
It's people used to like them.
But you're right. I mean, there are areas that people work with that don't immediately connect with the public. And that's, I think, where the individual comes in. Because usually the people who study them are madly passionate about something that you think, what? Even other scientists go, what are you doing with that?
But maybe I can relate it to caves, for example.
Right.
Here inside the state of São Paulo, we have a lot of caves. We have pretty cool bee and touristic caves, but they are definitely very far away from big cities.
Yeah.
They're all inside the jungle and national parks.
Yeah.
And Brazilian people really don't use to make some nature tourism and things like that. So, for example, if I want to say something about caves to the kids in the public school, many of them never saw a cave, never have been in a cave before, and there are no caves here in our city. So it's a challenge to bring.
It is.
This.
But so here's the thing: that if some bits of geology and science is trickier than others. I agree. It's kind of a sliding scale. But we have a much better deal than physics and chemistry and biology. So if you do physics, you have to do cosmology. You have to do solar system to make it interesting. Bog standard physics does not do well in the public. Bog standard lab chemistry does not do well. You have to set fire to things and explode. Biology doesn't do well. You have to make animals, kill each other. So geology's actually got a lot of interesting in caves, and I think that there is the way you connect is difficult, but if you could connect people, then would say, fascinating, they're amazing places, they're alien. Look at all the attention that happened with the Thailand rescue of the caves. People sat for days watching this, and all the graphics about the cave systems and the back. There's ways in almost everything. But I think the key way in almost always is the individual researcher. The passion that individual has is the gateway to the science. So they could be studying Precambrian microbes, and they can make it interesting. They can make it fascinating. But on the face of it, Precambrian microbes will mean nothing in terms of well-being and all the rest. And I think I need to be clear here. What I'm not saying is that every scientist should give up what they're studying and study socially relevant. I think that every scientist should at least be willing to stand up and explain what they do, because they're getting public money. And I think that in the long term, science itself needs to think about how it's going to address these. And it could be that some scientists have the things they like to do that no one else is interested in, they just do them. But maybe some of the other aspects need to be directed towards well-being. Because if in 50 years' time ocean acidification wipes out all the fish in the sea and we go downhill, people will say, well, why were you studying Precambrian stromatolites when all that was happening? So there's a tension there. And I think it's a case of trying to find what connects to people, and that will always be different. And I think it's an exploration with people, what works, what doesn't work. It's not anything immediate, but I would bet you 9 times out of 10, if you've got a very passionate scientist, that's the thing that will attract them. So 1, then 2, then 3, so then I'll see what I say. Yes.
Okay, I have a question. So you told us you started working with geocommunication 2002, 2003, and I was thinking about nowadays, like 2008, 18, you're using YouTube a lot, and if you're a student, bachelor student right now, what would you do to start working with geocommunication?
Right, that's a good point. So I'm going to come out of this to answer your question. Where's my glasses? I need glasses. Maybe I don't Internet. Internet. The diagram, folks in the workshop know what I'm talking about. If you look at where people get their information from generally, what you see is that if it's news and current affairs, then up until recently, television was the main source of information. But around about 2014, 2012, 2014, the internet goes past that. But if you look at general science and technology, what you find is that internet took over of television as the more important ones around about 2008. If you look at specific subjects, climate change, or fracking, earthquakes, whatever, it was the internet. It's been the internet all the way through since 2000. So I started, around about that time, and I thought television was the place to be. But what is very clear now is the internet is the place to be. So it's all very well making these programs, but nowadays we live in a fractured media landscape where you guys always live, and me included, most of the stuff we do is on the internet. Might be watching television, but it's on the internet. The challenge is, it's very easy to put things on the internet. We could have, well, it's getting streamed, we're just doing it now. What is harder is to have things found, because there's so much stuff out there. So quality and how people find things is really tricky. So you could make sure that in every video you have of geology, you have a cat playing the piano. That might help. But assuming you're not going to do that, then the same things happen. All these things that work for television, I think work for the internet. So you're about people and making it relevant and making it about wonder and awe and bringing yourself out. But I think that I wouldn't, if there are young communicators out there, I wouldn't wait around for El Globo or BBC to make a massive documentary using you as a presenter. I don't think that world kind of exists or won't exist for much longer. I think it's about YouTube, it's about making your own videos, and it's about putting them out, and it's about learning how that is an art, not an art form, but a way of communication. So definitely the internet. There was a question there, yes.
So first of all, thank you for your presentation.
Thank you.
As you said, we are an isolated group. Probably we don't have so much touch with the.
I think I said you weren't normal. That's what I said.
In that scenery, how we can get in touch with the industry, with like big oil companies or big miners, because I think that way we could reach more people, or I don't know.
So what do you think? You'd get in touch with them for what? To make their work relevant to you, or to change them? What were you thinking?
Yeah, try to bring them to our side. Like, try to show them that this is a good way to try to find people and like to be well-being to a better planet.
So yeah, it's an interesting one, because at first glance, or first off, it might seem odd. You might say, actually, do you want oil companies and mining companies? They have a bad press, out there in the environment. My view is, I talk to oil companies and mining companies all the time, and both, for oil and gas, it's pretty clear that most of the big oil and gas companies are also energy companies. They're moving into renewables. There's a new world coming. And in terms of mining companies, they also see that there's increasing importance of communities and trying to bring communities on board, if only to show the investment money keeps on supplying a social license. So I think both those corporations are trying to change. I think what will happen and they are trying to change, but it's still greenwash, it's still public relations. They are presenting themselves as really caring and about the planet. I think what will happen is, as this kind of stuff comes through the geology departments and science communication, people see how effective it is. They'll start to take on board some of that. They'll want that in. In other words, how can they not just advertise themselves, how actually can they engage with the local community in a genuine way, so the local community sees the benefits of the economic investment from a mine or from an oil borehole or something like that. I think that at the moment they're playing around with it, but I don't think they necessarily take it seriously. But I think that if we are producing geoscientists that are good technically, in other words, they're good geologists, but also they can communicate very passionately and effectively, oil companies and mineral companies will want them on their staff to be doing their jobs. So I think it's up to us to take the lead, not wait kind of for them. There's a question there, and then
there's a lot of competition on TV today.
Sure.
I think people are trying to get the audience as much as they can, as much attention as possible. Is there any kind of metrics that you can know how well you're doing? can science compete with other programs that are as fun as or as entertaining as scientific programs?
Yeah.
What is the future? Is there?
I don't know, because as I say, we're moving into this digital landscape where everything's broken up. I'm sure it's the same in Brazil. People in the UK don't watch programs in a scheduled way. They watch it whenever. They download multiple things off of Netflix. They sit in the bus watching. You know, my daughter the other day, we decided to watch a series on Netflix, and she said, "Oh, I watched them the other night." She watched 8 programs, one after another, in one night. So I don't know how you would do. You know, how do you do the? You can do downloads, and we can do audience ratings. We can compare audience ratings for science programs against other types of programs, and I'll tell you, science doesn't rate anywhere near as well as art or history or some of the other things. But I think the question about how effective it is hard to judge. So somebody could download a, you know, I don't know if you've ever, I've got a YouTube channel and you can put YouTube videos up and you see, oh, it's been watched, I don't know, 500 times. And then you go and you do the analytics and you see that vast majority of people watch the first 30 seconds or 1 minute and then didn't watch it. So you might look and say, oh, I've had 500 views, but actually, no, you've not. You've had actually 100 people that stayed to the end. So there's lots of data, but what it means is hard to judge. I do
Is
think,
there incentives from the networks to continue doing programs like this, or?
I don't know, I'm the wrong person to ask for the Brazil. I mean, in BBC, science is still seen as an important minority issue to have. And every so often they bring it up in a big flashy, big series and say, hey, we do science, but then it disappears back down again. So I'd say they would say it was important, but I'm not sure on the big scheme of things it's terribly important to them. I don't know, I mean, I think we are in a new media landscape, actually, and I think that the internet does throw up lots of opportunities and problems, and how we evaluate our effectiveness in that landscape will be a really important part, actually. Yeah, there might be some media people here with better ideas about how we do it, but I don't know.
Thank you.
Any other questions? Oh, there's one over there, then I'll not forget you.
I'm wondering about the scientific method of geology. It's a problem, or is it a helpful thing?
So the method of being a geologist? I think
the scientific method.
The scientific method. Yeah, I think it's a good thing.
Sorry for that.
Yeah, I think it's a good thing. I think we have a number of skills that differentiate ourselves from other scientists. So our brains get wired differently to other scientists. So an example is we deal all the time with incomplete data. We never have all the data. You know, these maps, that map there suggests that every part of Brazil is covered in exposed with rock, but you know that's not true. It's hardly any rock sticking in. But we still produce a map like that, which is pretty impressive. We've got this deep time, millions of years. We deal with the whole planet. We deal all the time with this world down there in the subsurface that no one else even thinks about. All of that means that our head is in a different place. And you could see that as a disadvantage, but I'd see that as a really strong advantage about the way we see the world. We see it in this holistic way. And I think we take those skills into the workplace, even if you're not a geologist, if you're working in a bank or a shop or whatever it is, we use those skills. And I just think we see the world differently from other types of scientists. So I think it's a massive, massive plus. I think it's just that people out there think we study stones. And that doesn't transfer very well. But when we actually start talking about what we do and all the rest of it, you know, that idea of us not being normal comes to the fore, and that's in a good way. So I think the scientific method is really important. I think it's probably less important. You can identify muscovite under the microscope in the big scheme of things. When you go out into the world, you probably won't do that too many times. But I think the skills that you use to identify muscovite down the microscope, the thinking skills, are ones you will. So I really think the geoscience method is critical in the way that we would be portraying the world. And a chemist would portray it a very different way. Physicists certainly would portray it a very different way. Maybe the last question here. I'm looking at Glory for time. The last question.
You know that here we have many problems about how much money the government decides to invest in science. And so most of the politicians, they are at which of the groups? I know that they are not science fans, and how to convince them that science is important.
That's a very good question. The question is we're not quite sure which group the politicians are in of those different science audiences, but they don't seem to be science fans, and therefore they don't seem to take much notice of things. So I used to not say too much about politicians because I thought I didn't know about policy and they're a different world. I understood the public. I've changed my view on that. I think the politicians are just like the public. They get their science from television and newspapers and friends, unless they're a science minister or a high minister that's going to advise them. They are not scientists by background, but they're confronted quite often with scientific issues. So if you think about it from their perspective, they don't have a science background, they're defensive about science, they might be in one of those categories, but they don't know much about science, but they're asked to. And they've got all the misconceptions that the public have as well. So I think if you can, it's kind of what I was saying in the workshop today, if you can communicate to the public, you can find a way of reaching some person living in a village, you can find the same devices, the same techniques, the same approach works for a politician, slightly. You have to flatter them more, the same basic techniques. So, I don't know why I put this one up, but trying to understand how to reach the public. The key things are, you don't start from where you are, you start from where they are. That's always the rule in communication. Wherever your audience is, you start with them, you design it for your audience. For the politicians. What do the politicians need? What do they care about? What are they interested in? How do you make it important for them? Think about their world, and then think, how can I help them with their world from science? Because if you go to a politician and you say, I want to help you, I want to make you look good, they will welcome you with open arms. They say, come on in, make me look good. If you tell them, you're stupid, you don't understand this, let me explain how it's going to be, they ignore you. So I think that we don't probably do enough to try and understand how a journalist works, and same argument for journalists, how a politician works, to try and put ourselves in their shoes, to understand their challenges, their pressures, and then to think, how can science help them? So one thing would be to bring some politicians into the departments and get them to talk about how they work and what their challenges are, etc. And I think once they see science being useful to them, you'll get your money. You'll start to get some more money in first. But unless they see it being useful to them, or unless their public is pushing them, then they're not going to do it. Because why should they? But it's a problem everywhere, even in the UK. Thank you very much. I think we should move on. You can ask questions.